All right, welcome to part 2 of the prerequisite skills lesson. In class, you were responsible sort of for reassembling some notes here, and this is the take-up video. Notice that the simplify state restrictions, it doesn't matter the order that you put these in, you might have put them in any order, but the first one here that I have is adding two rational expressions together. So I know since I'm adding or subtracting, I need a common denominator, right? Need a common denominator, which is the lowest expression that both of these brackets will divide into, and there's the common denominator, and then you simplify the tops, and then the restrictions are, well, the bottoms can't be 0, right? I can't divide by 0, so x can't be negative 2 and 1. The second one is a dividing. Remember, to divide rational expressions, we flip and multiply. So to divide, we flip and multiply. Now notice that if I were to actually multiply this across, it'd be a huge mess. But what do? The trick or the strategy in dealing with rational expressions is to factor and simplify if you can. So we factor each of these things, grade 10 style, factor, 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 cancel, 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 and you end up with this much, much easier expression. Notice at the end, when both of the expressions cancel, I end up with a 1, not a 0, right? When I divide something into itself, you get a 1, and then I multiply across, and notice that in this expression, x can be anything. But where do the restrictions come from? The restrictions comes from the top. Anytime I'm dividing by 0, I have to worry about it. So, you know, from this expression, x can't be negative 1, x can't be negative 2. And in fact, if I'm dividing by 0, x can't be positive 2 either, because if x were positive 2, I'd get a dividing by 0 over here. So all these are restrictions. And the idea here for these is this expression is equivalent to this expression except for at the restrictions. So this big long thing is the same as this thing except for here where this original expression is undefined. The last one is just a plain simplify. It's not an add or subtract or multiply or divide. I factor out the 3x, simplify, number parts, and now that it's factored, notice I can't just cancel here. I need to factor first and then cancel factors. Right? I can't cancel terms, I cancel factors. That's a big deal, that mistake that some people make, that thinks that, oh, I can just cancel out an x here and an x here. No, because that's a term. You cancel factors. So I factor out the 3x, and 3x goes into itself once, and into this expression, 3x squared times, and then there's the restriction. This is actually a linear equation, and how do I solve linear equations with fractions in them? Well, usually I want to kill the fractions. Kill the fractions, you multiply by something that'll get rid of all the fractions at the same time. So the common denominator, you multiply by the common denominator 15, and after you multiply by 15, what's actually left when you cancel? Divide 3 into 15, I get 5. Divide 5 into 15, I get 3. And so then this expression is 5 times this minus 3 times that. 5 times this minus 3 times that. And don't forget to multiply the right-hand side by the 15 as well. And then grade 9, actually this whole question is a grade 9 question. Grade 9 linear equations, and you end up with x equals 4. That's the solve. A graph, well, remember that is one of our original parent functions from grade 11, and so all I have to do is identify what the numbers do. Well, this is a vertical stretch. This moves it up 3. This moves it opposite in the direction of x, where this moves it right 4. And usually we do our stretches and squishes first. So there's the original equation. Vertical stretch by factor of 2. The one nice point goes to 2. The vertical stretch by factor of 2, and then I've moved right 4 and up 3. Probably you'd skip that, and once you get the stretches, you do both switches on the same step. if you were doing this in grade 11 or even in unit 0 where we first saw transformation of functions. There's your homework, and there's an FAQ that goes with this, and that's it.